Objective 12, know the possible organic products formed from oxidizing primary alcohols and secondary alcohols and know the catalyst involved. So with the primary alcohol, if I have propane, I'll make it a primary here. So I've got all my hydrogen here. If I use the catalyst, it's going to be potassium dichromate. And it's going to have a classic color change from orange to green. And I just remember that like a traffic light, you know, red to green, orange to green. The green light means a reaction happened. Alcohol was there. And that's what they use in breathalyzers to know how much alcohol is in there. Not only if there is alcohol, but how much. But when you oxidize this, it's called oxidation. So you're adding O2 to this. First thing that happens is two hydrogens get pulled off of here. And it takes one from the carbon and one from the oxygen. And even though we think of OH as being a hydrogen bond, that's just the interaction between molecules. The actual bond holding the O and H together is just a covalent bond, which is different. And the other thing you should be aware of is this is going to require heat. So usually around the arrow, we show that you need to do this in the presence of oxygen and heat. So these two hydrogen are going to be pulled off or liberated. And if you want to show the H2, you can show the H2. Otherwise, since we're not interested in the H2, you can just show the product remaining. And so this has become a double bond. The two of the hydrogens are gone, but one is still here. And then my other hydrogens are intact. So when this happens, this becomes an aldehyde. And I remember then aldehyde, the oxygen is hiding the hydrogen, or it's eliminated the hydrogen, however you want to think of it. It's when the hydrogen on the oxygen is pulled off or lost, then we form what's called an aldehyde. Now you could go on and continue heating this in a process called reflux. And if you did that, again on your arrow here, you'd show that you have oxygen, heat, and then you'd also mention this idea of reflux. And reflux basically just means you have it in a container where the aldehyde can't escape. So it heats up and it's going up as a vapor, but it doesn't have a tube or a way to get out of the container. So eventually it condenses and falls back in there. And the aldehyde gets further heated with more oxygen. And when that happens, then an oxygen gets added back right here. And so I'm going to end up with, oops, I'm going to end up with my hydroxyl group up here. I still have my oxygen there, and then my other hydrogens in here. So I end up with a carboxylic acid eventually. So those are the two options for a primary alcohol. Secondary alcohol, same catalyst, and basically the same process as our first reaction here, except because the OH is on the center, when I pull off two hydrogen, and again I need O2 and heat, and I've only got two hydrogen to pull off, so I'm left with a double bonded O and no hydrogen, which is good because there's only 4 bonds available there. But when the oxygen is double bonded in the center, this is called a ketone instead. And as far as heating it further won't matter because there's not another hydrogen on this carbon to react with. So the reaction is done at this point. And then I didn't mention tertiary alcohols on here, but you should be aware they're not going to react or oxidize because there just isn't room to get into that OH group with 3 methyl groups surrounding the carbon.